Alright, so in this equation, I have x to the power of 4 plus x squared is equal to 20. So to solve this, what I'm going to do is first start by subtracting 20 on both sides, so we can have all our terms on one side. So I get x to the power of 4 plus x squared minus 20 is equal to 0. Now this may seem like a quadratic equation, but it's not, because we have the power of 4 as our primary term, and then that's led by the power of 2. And in a normal quadratic equation, we have 2 as our primary, then we just have 1, and then we have some constant c. So how are we going to solve this? Well, we can't factor this out by using the quadratic formula, because this is not a quadratic equation. So to solve this, what I want to do is rewrite this as x to the power of 4 plus x squared minus 16 plus 4. So I rewrote 20 as 16 plus 4. And the reason I did this is because negative 16 is the same thing as negative 2 to the power of 4, and negative 4 is the same thing as negative 2 squared. So now notice how I have something in the power of 4 and something in the power of 2, and they're both the same. Now I can put the powers of 4's together and the powers of 2 together. So I get x to the power of 4 minus 2 to the power of 4 plus x squared minus 2 squared is equal to 0. Now 2 to the power of 4 is 16, and 16 is the same thing as 4 squared as well. So I get x to the power of 4 minus 4 squared, and I have this plus x squared minus 2 squared. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 is the same thing as x to the power of 2 times 2, which is equal to x to the power of 2 to the power of 2. So now I get x to the power of 2 to the power of 2 minus 4 to the power of 2 plus x squared minus 2 squared is equal to 0. Now notice how everything is in the power of 2, and if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So we're going to use this property on these two groups. So I first get x squared plus 4 times x squared minus 4 plus x plus 2 times x minus 2 is equal to 0. Now we can use this property again on x squared minus 4 by rewriting as x squared minus 2 squared. So that's going to equal x plus 2 times x minus 2. And I have this plus x plus 2 times x minus 2 is equal to 0. Now I'm going to factor out x minus 2, so I get x minus 2 times x squared plus 4 times x plus 2 plus x plus 2, which is equal to 0. And notice how we can also factor out x plus 2 as well. So actually at the start, what we could have done is just factored x squared minus 4 out, but now we're going to factor out x plus 2 as well. So I get x plus 2 times x minus 2 times x squared plus 4 plus 1 is equal to 0. So x plus 2 times x minus 2, like I said, was x squared minus 4. And I have this times x squared plus 4 plus 1, which is x squared plus 5. Now this is equal to 0. Now this gives me two equations. I get x squared minus 4 is equal to 0, and I get x squared plus 5 is equal to 0. So for x squared minus 4 equals 0, I can add 4 on both sides. So I get x squared is equal to 4, and this is equal to positive or negative 2. And for x squared plus 5 is equal to 0, I get x squared is equal to negative 5, and I get x is equal to positive negative square root of negative 5, which is equal to positive or negative square root of 5i. Alright, so in this video, I'm going to be solving the equation 8 to the power of x is equal to 88. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to first start by rewriting my equation down here so I have a little more solving space. So my equation is 8 to the power of x is equal to 88. Now I'm first going to start by taking the log on both sides. So I get log of 8 to the power of x is equal to log of 88. Now, if I have something in the form log of a to the power of b, I can move this exponent b to the front, so this is going to equal b times log a. In this case, I have log 8 to the power of x, and I can move x to the front, so I get x times log 8 is equal to log 88. And the reason this property is so useful is because before, x was an exponent. And for our equation, if x is 1, I get 8. If x is 2, I get 64. And if x is 3, I get 64 times 8, which is 512. And we want to find what value of x results in 88, which is somewhere in between 2 and 3, but we don't know exactly where because it's going to be a decimal. So we can't really find the exact value as x when x is in exponent form. So this is why we can make it into a real term using this property, and now it's much simpler to solve for it. So now I have x times log 8 is equal to log 88. And I want to isolate x because that's what I'm solving for, so I'm going to get rid of this log 8 by dividing both sides by log 8. So now these two cancel out, and I get x is equal to log 88 over log 8. Now log 88, I can rewrite this as log of 8 times 11. So I have log of 8 times 11 over log 8. And now another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So log of 8 times 11 is going to equal log of 8 plus log of 11, and I have this over log of 8. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, which is a simple fraction property. So log 8 plus log 11 over log 8, I can write that as log 8 over log 8 plus log 11 over log 8. Now, log 8 and log 8 cancel out to get 1. So I get 1 plus log 11 over log 8. So now all that's left is to plug in the actual values of log 11 and log 8 and solve. So log 11 is equal to approximately 1.04, and log 8 is equal to approximately 0.90. So I get x is equal to 1 plus 1.04 over 0.90, which is equal to 1 plus 1.16, meaning x is equal to 2.16. So this is my answer.